Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I have this gree 2-ton inverter AC board. In respect to the fault condition, we will see the function of this circuit, working principle, how this circuit is working. If we know the basics of the circuit, we can take approach to any fault condition whatsoever. If it have communication error, communication failure, it have IPM fault, overcurrent, temperature sensor failure, or it is totally dead. If we understand the circuit, at that time we can make a pinpoint location that this component is bad, that this component is bad, this component is not working in this way. For that purpose, we need a best understanding for the circuit. Let's start. Marked fault condition E6. Communication failure between indoor and outdoor units. Sometimes this error code list is placed on the board, and sometimes we need to find its service manual or catalog, user manual, operator manual. There we can find this list. If we have this list and any fault which is being displayed on the indoor unit display, then we can locate where is the problem. Here is also blinking code. LED is blinking 6 times, LED blinking 8 times. There are LEDs on the board. It will blink 6 times, 8 times, 5 times. That will indicate where is the problem. Let's open it. Connection diagram. Line and neutral are entering in the board. From the terminal box, it is reaching back to indoor unit. In this model, the main power is connected here at outdoor unit. Line neutral. Then there is another wire, that is communication wire. So 3 wires are connected with indoor unit. It have connection with compressor, overload protector, different sensors, outroom temperature sensor, exhaust temperature sensor, 4-way valve, expansion valve, and cooling fan. Now when we remove this cover, very important safety point that always check voltage on these capacitors. Even it is removed from the unit, it is not connected to power, but always before touching to the board, verify the voltage. Sometimes this capacitor have voltage. Normally these are charged at 400 volt DC. Never touch the board until you will discharge it. After discharging, it is safe to remove. Three wires are here, blue, brown and black. Black is communication wire. Pull back the insulation sleeve to rear side and press lock from this clip and pull back the connector. There is a special lock on this clip. Press it and pull it back. Now our board is free. We can see it was reported with communication fault. But we can see the fault condition. This IGB damaged. Now we have this board. It have this output connector. One output connector is here. Input 4 wires here. One is the earthing wire, chassis ground, neutral, line, communication. Here are sensors, overload protector, 4-way valve. This board is used in gree. Either it is LG, Diakin, Frigire, Orient, Airwell, Panasonic, Hitachi, any brand. Forget about the name. Working theory will same. Design may be different. Here it is using 3 capacitors. Maybe in the other board 3 capacitors are here. Here choke is installed here. Maybe in the second board choke is installed in outside reactor. This board is rectangular. Maybe the next is in square shape. Maybe in other brand this IPM section is separate. This section is separate. This section is separate. In some other brand power supply is installed separate. In some other brand this communication board is separate. I guarantee if we understand the function we never need these diagrams. These diagrams, if we study thoroughly in full detail, every diagram is 99% similar. Either it is 1 ton, 2 ton, 1.5 ton. Either we have Chinese brands. Everyone have same working principle. It have some major sections here. Input section. Here we apply line and neutral. EMI filter. This EMI filter, it is used to protect this board, this device from external frequencies entering in the board. And it will block all the switching noises, switching frequencies that are here. It will not allow to pass outside. So this is barrier. Here is over voltage protection. It will protect the circuit from any high voltage strike. When we are applying line voltage, in line frequency 60 Hz, 50 Hz, there are many type of noises. High frequency noises will be removed from class Y capacitors. Then inrush current protection, that is PTC, NTC, like that. After that, AC voltage will reach to bridge rectifier. Bridge rectifier will rectify the voltage and these voltage will stored here. Meanwhile, we have small power supply here. This power supply receives voltage from the line voltage, rectifies and stores on this capacitor. Then it have its IC here, smps controller IC, transformer. It will provide 3 different type of voltage to power up this board. To provide bicycle voltage to its microcontroller and IPMs. Here it have communication section. Here it is PFC section. This PFC section is voltage booster. 2 IGBTs, 2 diodes, inductor, reactor. It will rectify voltage and it will maintain the voltage on this DC rail, these 3 capacitors. When it will receive order from the master unit, that is indoor unit, this board is slave. Master board or master microcontroller is indoor unit board. Indoor unit will send command to turn on compressor. It will monitor different pressures, temperature, ambient temperature. It will check the voltage value. If the voltage are low, then the rated value, it will provide order to this PFC section to boost up the voltage. It will maintain the voltage here. When the voltage are maintained, it will switch this IPM. Here we have DC voltage. It will provide 3-phase voltage, variable frequency, variable voltage. It has second IPM here that will drive the cooling fan. Here are sensors and its related circuit. Because it is electronically controlled, the IPM is semiconductor component. These IGBTs are semiconductor components. Anytime, in any condition, if there is overcurrent condition, if there is error, it will monitor that error. It will continuously monitor the voltage. If the voltage will drop, it will generate error message. to display in the indoor unit. Depending on the fault condition, it will turn off compressor, it will turn off outdoor fan. If the temperature is maintained inside, it will turn off the compressor and it will monitor the exhaust temperature, and it will keep running the cooling fan, and then it will turn off the cooling fan. When the order will receive, it will turn on cooling fan and it will turn on compressor. We need any function to drive expansion valve, to drive heat and cool. This processor will receive order from indoor unit through this communication wire. That code will be executed here and it will provide order to related circuits. Line, neutral. It is provided to EMI filter, MOV section. Then there is inrush protection, inrush current protection, fuse. Then here it has soft start circuit. These components are in this zone, in this corner. In the line and neutral, in parallel there is MOV, these resistors. Then it have class X capacitor. I am drawing just only one stage, it is using two stages. Then it have common mode capacitor. Both differential mode noises and common mode noises will be removed from this stage. Then it have PTC. In parallel to PTC there is relay. Then this voltage will reach to bridge rectifier. AC, AC. Positive, negative. When we apply line voltage in this circuit, after bridge rectifier we have this heavy amount of capacitance. If the input current is not controlled in the startup time, at that time it can damage bridge rectifier, it can damage any component in the circuit, or maybe it will damage the fuse. To protect it, PTCs are using here positive temperature coefficient resistors 1 and 2. In parallel to these PTCs there is a relay. At same time, in parallel this power supply will start up. When the voltage are in safe limit, it will turn on this bypass relay so that this PTC will bypass and current will reach to next circuit. Here AC, bridge rectifier, positive, negative. These positive voltage are reaching here. Here we have these inductors, positive, negative. One diode, second diode. Normally we will provide 300 volt, 310 volt here at DC rail after bridge rectifier. When this circuit will start switching, it will boost the voltage here, for example 400 volt, 380, 350. It depends on the designer how he is designing the circuit. If the line voltage are below the limit, it will maintain this voltage level here. Same time we have AC voltage. These AC voltage are reaching here to smps circuit. This valve section. It will provide 5 volt, 15 volt, 3.3 volt, like that. These voltage will reach to microcontroller, MCU, microcontroller and other electronics. We have another circuit here, communication circuit. It will receive command from indoor unit. Here we have MCU, microcontroller will receive command. When it will need to send any information to indoor unit, it will send to this section and it will send to one wire. We have 400 volt DC here on these capacitors. Here we have IPM, Intelligent Power Module. Basically it is set of 6 IGBTs with driver IC. It will receive 6 commands UVW and it will receive this voltage. it will provide 3-phase to the compressor. The same set is used here for the outdoor fan. 3-phase. We are injecting AC voltage, then we rectify to DC, then we processed it in the booster section, voltage booster. Voltage booster will maintain this voltage at this level so that this speed will not affect it with variation in the input voltage. Microcontroller from here, it will send commands, these commands here, and it will monitor the load. It is sending commands, it is monitoring the load, it is monitoring the current, how much is current, how much are voltage. Same time it is monitoring temperature from these sensors, exhaust temperature, different readings which are involved in the circuit. If any time current from here is increased, current from here at each phase is increased, same time the information will be transmitted to microcontroller and it will take necessary action. After that action, it will intimate to the indoor unit. We provide neutral here, line here. In the line at this point we have 30 ampere fuse. In the neutral there is this filter, and in the line the same filter. It is dual line filter. In this section, if we see neutral is reaching here at this point, here we have 1, 2, 3 over voltage protectors, MOVs. If there is any high voltage strike, it will blast immediately. Here we have class X capacitor. High frequency noise will eliminated here. Then we have class Y capacitors 1 and 2. It is connected between line to earthing point. Here is earthing point, the green wire, yes, this one. From neutral, this wire, it is connected at the same line. Then we have second stage filter. Here we have capacitor, class X capacitor. At the same point we have this capacitor, class Y capacitor. It is connected also to earthing point. Any common mode noise, switching noise, any ringing factor, any communication high frequency noise, that will be eliminated here from these 4 capacitors. It will be grounded directly from here to the chassis ground. Fuse, class X capacitor, first stage filter, class X capacitor, second stage dual line filter. Then we have this capacitor, that is also class X capacitor, and here is lightning arrestor. It is also connected in parallel. Then if you see this point, this is common line. Common line is reaching here, then it is reaching to this rectifier set, and we have capacitor here, that is to provide the voltage for the communication line. 2 optocouplers are here, communication wire here. All the communication data will be received and transmitted at this stage, and it will be communicated to the microcontroller. Line voltage here will reach to this first PTC. This is 50 ohm PTC from here to here, then from here to here. It is reaching here at this point. And here we have relay, bypass relay. From here, these voltage will reach to this point. These will provide it to common points, and at the same time voltage are reaching at this rectifier set, and these voltage will reach to this capacitor, that is capacitor for this low voltage power supply. It is TNY278. It is using TNY278 IC. Maybe in other boards it is using another IC, but the working phenomena will remain same. This neutral line is directly coupled to the negative side of the capacitor. Positive voltage will be rectified from this line. Positive voltage from here are reaching to this point, and these are reaching to transformer winding. Drain pin is connected here. Here we have diode, capacitor, and these resistors. 1, 2, 3, 4. 4 resistors, and this set. Resistors are in back side. This capacitor, this diode. These are snubber circuit. Here we have TL431, optocoupler, VCC capacitor, rectifier for bias winding. This is fuse for this section, fuse number 2. Here is NTC. This NTC is current limiter for this section. These two PTCs, this one and this one, these are soft starter circuits for the next stage. Neutral will reach from here, from this point. It will enter in board and it will reach here. Neutral here. Line voltage after processing, after passing this network, line voltage will reach here. In the initial stage, this circuit will remain off. After that, when this circuit will turn on, it will turn on this relay, small relay here. When this relay will turn on, at that time, these PTC 1, 2, these will reach here and it will provide path for slow charging of these capacitors. When these capacitors will maintain some sufficient level, in this period, this microcontroller is also active. At that time, it will generate order to turn on this relay. So this relay will turn on. When it will turn on, it will switch line voltage directly from here to here to this. Before this, line was connected here through this relay and it was reaching here. But now, when the voltage are maintained, at that time, it will bypass this PTC section. In case there is any overcurrent condition, IPM is drawing overcurrent, IGBTs are damaged, anything wrong, bridge rectifier is damaged. When the voltage level at this stage will decrease, from this line it will sense the voltage, immediately it will turn off this relay. When it will turn off this relay, all the free flowing current will decrease by adding PTCs in the circuit. These are positive temperature coefficient resistors. When there is overcurrent condition and current will flow through these components, it will cause to increase the temperature because it will dissipate power. When it will dissipate power, its resistance will increase more and more, so that the next circuit will cut off and it will drop all the line voltage here, and at the same time it will intimate the indoor unit. And sometime when there is huge current flow, it will turn off this power supply as well. So this board will turn on once, then it will turn off immediately if there is overcurrent condition. In the DC rail, positive voltage are coming out from this point, negative from here. Negative from here, this point here. Here is 8.2 milliohm resistance, two resistors in parallel. From here, current will pass, it will go to these IGBTs, this section. Positive voltage are here, as I discussed here. Positive voltage are reaching to coil. inductor, this point and this point. We have two inductors here. Each inductor have two portions, two coils. One coil from here to here. Inductor core is here, but it have two sections, 1 and 2. Both are in parallel. Then from here to this point, here to this point. This one here to here, here to here. We have two coils in series. And if you look at this end, it is reaching to collector of this IGBT. And this portion from here, it is reaching to this IGBT. Here I draw one coil. This is the second coil. So we have two coils in series. Here is IGBT driver. It is half bridge driver. It will drive this one and then this one by one. And these coil points are connected to this diode. When it will turn on, it will connect negative line to the inductor to the coil. When negative is connected here, this diode is reverse biased. So it will block the voltage. No voltage can return back here. When it will flow heavy current here, it will store magnetic energy in this coil. When this pulse will turn off in this period, this magnetic field will collapse. These voltage will come in series with this voltage, the DC rail voltage. Now this voltage plus this voltage will come in series and it will pass to capacitor. This capacitor will receive elevated voltage. That are our required voltage. At the same time, from this point, from the voltage divider network, same voltage are reaching here to the microcontroller. So microcontroller will monitor the voltage level and it will adjust the duty cycle, turn on time vs turn off time for this booster section. This current will be monitored all the time to protect the circuit from any abnormal condition, any overcurrent condition. Then here is IPM, Intelligent Power Module. Some IPM have one emitter input. In that IPM, three emitters of the low side IGBTs are connected together. And there will be one resistor. Some IPM modules have three separate emitters, and each emitter will have its own resistance. If we see here in this board, we are providing positive voltage here, negative voltage to the resistor, and same voltage here. It is current sensor resistor. When the current will flow, it will drop voltage here. That amount of voltage will be provided to microcontroller to monitor the current value. One IGBT will turn on, it will switch positive voltage to single one phase. The second will turn on and it will provide to the next winding low side. So it will make combination high low to provide three phase. These current pulses, these will provided to this comparator IC. It will compare this amount of current anytime. If this current will increase, immediately it will intimate to the microcontroller that there is overcurrent condition. Same here, this IPM, it will receive 6 pins input. If we check here, the small pins, 6 lines from here, these are coming from this microcontroller, and it will receive signals from the same UVW output, 3 phases. It will receive feedback for each cycle as a bootstrap voltage. 3 capacitors are here. These 3 capacitors, 1, 2, 3. These are to provide biasing voltage for high side IGBTs. Same here, ULN 2003. These are to drive expansion valve and relays. 1, 2, 3. In this communication section, we have two types of optocouplers. One is for reception, the second is for transmission. This one, it have LED side in this area, in this side, so it is for receiving mode. When this processor, this board will send any data, it will send from transmitter. This capacitor for communication voltage, and here is memory IC, programming connector. Here is high voltage protection for DC rail, decoupling capacitor here. If we compare the diagrams, all diagrams are approximately similar. Here, input protection circuit, rectifier section. Rectifier, it will provide voltage here. Sometime, yes, here is monitoring DC current. In some circuits, there is CT, current transducer, that is connected at input line. There is a transformer, current transformer here. Current will pass through that transformer as it is used in welding machines. How much current is flowing in the circuit in parallel? It has small secondary winding. It will provide it will provide voltage. That voltage will proportional to the current flow. That will be rectified, and processor will measure that voltage. How much voltage are coming out from that CT, current transducer or current transformer. So it will measure the amount of current. This section is smps section, power supply for biasing up this circuit. Then it have different monitoring circuits, communication circuit. Here it have IPM, first IPM, second IPM. This for compressor, this for fan motor. The same 6 lines are reaching here, similar 6 lines are reaching here, so it will receive drive signal. If we check this one, it is for Samsung. Here every section is divided in portions. This from LG, it is the same. IPM is shown here, microcontroller is here, communication section here. This is also for LG model. It's for higher control circuit and module board. It will drive the IPM, the same here. IPM, it will provide UVW. Communication line here. It will depend on the type of the board. It is also higher board. Sometime driver module is separate. Sometime IPM driver module is same. It will receive command and it will start functioning. This for gree. It will receive voltage, protection circuit, then reactor. Sometimes reactor is on the PCB and sometimes reactor is outside from the PCB. The same. It will provide boosted voltage, and then here it have power supply, that is IPM. It will provide UVW, and microprocessor will control the function. Then here is Shinko, these Chinese brands. All the boards most of the time are Chinese branded. Either it is in LG or any brand. So Chinese manufacturers have approximately similar designs. These all boards are 99% similar to each other. Just only component value will change, part number will change. In this Shinko brand, we can see this circuit is divided. Each section is divided. In upcoming video, we will perform practical testing and we will monitor different signals and we will troubleshoot this board, why it is giving communication error. If you have not subscribed my channel, subscribe it and press bell icon button so you will be notified for my every new coming video. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching.